Alright, so today's biweekly contest, we'll look at the first three problems. First problem states that we are given x and y. X represents the number of coins valued at 75, y represents the number of coins valued at 10. And we are having two players, Alice and Bob. The first turn is going to be Alice's, and she needs to take the number of coins such that the value is 115 exactly. And that can be possible only in one scenario where there are 175 coin and 410 coins. There is no other possibility. And this will continue. The turn will go to Bob. Then it will go back to Alice until one of them is not able to, because this will get exhausted, right? After one turn, it will turn into x equal to 1 and y equal to 4. Sorry, y equal to 3, since 4 points will be used in the first turn. And similarly, this will continue till x is greater than 0 and y is greater than 3, isn't it? If it's greater than 3, we'll have 4 or more values, right? That's why we'll have something called turn to determine which is the winning person by the end of the loop, which will be a while loop. This will continue till x is greater than 0 and y is greater than 3. And I'll reduce x by 1, I by 3. Turn will toggle every time. And if turn, by the end the loop ends, if turn is equal to 0, which means this was Alice's turn when the loop got over, right? This means I need to return Bob as the winner. Otherwise I'll return Alice as the winner. The time complexity will be O of n, isn't it? Sorry, this will get exhausted by 4. We need 4 10 coins for a value to be equal to 115. Let's see, submit it. Time complexity will be, I believe, O of n, or probably there could be a log factor as well, but I think it should be O of n. The second problem, minimum length of string after operations. Basically, we are given a string. We can do one operation on it. That is, we can choose one character and we can remove the character coming after it and the character coming before it. Alright, let me take this example. A smaller example will be fine, but okay. Anyways, this example is also good. See, now if I want to minimize the string by using this operation that states that I need to choose one character, any character, and I can remove the same character coming after me and the same character coming before me. So I can't choose B because there's no character B coming before B itself, the one that I choose. So I can't choose B. I can choose A. So this, the one that I choose, need not to be removed, but the one coming after and the one coming before needs to be removed. So right now the length becomes 1, 2, 3. Is there any other character that I can choose? I can't. So basically the intuition that you get if you try to run more of such examples, you will find that essentially we are, you know, uh, we are more, what should I say? We are more fond of the frequency if it's greater than 3, or scientifically, yeah, it's greater than 3, isn't it? If it's greater than, or actually greater than 2, if it's greater than 2, which means it's 3 or 4, I can choose one such character and I can basically reduce it by 2 amount, isn't it? I chose this character because it had a frequency 3, or actually 4. We have 4 A's, and we removed 2 A's by doing this one operation. So we'll continue till it is greater than 2. We can keep on reducing it by a factor of 2. And we'll do that for all the frequency of characters that is appearing. B is appearing once, so I can't do anything since it's not greater than 2. C is also appearing 1, I can't do anything since it's also not greater than 2. And that's by the end we'll need to return the number of uh, operations that we performed, or no, the minimum length, right? So whatever the length after removing, after doing all such operations that is possible, will return the answer. Alright, so we can have a frequency inside an ordered map, or even better, we can do something called bucket sort since we have limited alphabets. Uh, this I'll call it bucket. Let's not switch keyword, thank God. This will be 26. I go through all the characters that is present in the string, and I will put it inside the bucket I minus a plus. I go through the bucket, I'll have something called answer in which my uh, yeah, this will be my length. I keep on adding I keep on adding till I get the minimum length. I'll see what's the frequency right now. That I can get it from bucket of I. This is the frequency. If it's greater than 2, in that case I can change it down to by a factor of 2. By the end, whatever is left inside the bucket is my uh, value which is going to contribute into my answer. That will be bucket of I. This is my answer that I return. Let's see if this works. Okay, what's going on? This is going to be S of I. I'm so sorry. It does. Time complexity will be O of n again, and space will be, I think, O of 1 since it's constant. Now, the beautiful problem called minimum array changes to make differences equal. Okay, so here we are given a numbers array, basically this one, for example, and we are given k equal to 4, and we are asked to uh, do certain operations on it such that the difference between the last element, between the second last elements, between, you get the idea. Basically, we are trying to take this 0, 1, 2, 4, 3. By the way, this is always even, the length of this array, and we are trying to equalize these differences. This is right now 2, the absolute difference. This is right now 3, oh sorry, 4. This is right now 1. So we have these frequencies, I mean these differences, and we need to equalize this. How can we equalize this? We can just choose one. We can fix, suppose this should be the difference. So we can essentially leave this but take the process the other ones which are not equal to 2 right now, it is 4. So I need to change either 3, I mean either 0 or 3 or both such that its difference is 4. How can I do that? I can essentially also, I mean, the value that I will be changing needs to be in the range 0 to k. That's what k means. K signifies here. So I can change 0 to any value between 0 to k. I can change 3 to any value between 0 to k. I can change either of them, or I can change both if I require. Uh, so if I want 4, what should I change? I will try to, minimize my operations by doing only one change, because I can definitely every time reach uh, the value or the difference that I want by changing two values, but we are asked to find the minimum number of changes, right? So we'll always try to get it using only one change in between the two values. So 0 and 3, what are we going to change? We can change 3 to 4, and that's the only way we can do it, because if I try to make 0 to 1, 2, or 3, we can't do anything about it, right? I can change 0 to 4 and then 3 to 0, but that's the worst thing that we want. So 0 to stay 0 and 3 to stay 4. Now the difference is 4. Fine. Now we get the idea. 1, since we fixed 2, this took me one operation. And what about 1, 2? I need 2. So I can change either 1 to 0 or 2 to 3. That will take one operation. So this takes two operations. Similarly, if I fix 4 and change the other differences to 2, in that case I will also end up getting 2, I think, or even more. So this is the answer. Now the naive approach will be to count the number of differences, the frequency of differences. This is currently 1. Suppose this was 2 and this is 1. This is not 2 in this example, but I'm just assuming that this was 2. There is another suppose value that is 0, 4. Now this difference is 4 again, and the number of 4s is 2 now. So this is the frequency. The naive approach says that we can uh, fix this, the one that is highest occurring in terms of frequency, and we change the other frequencies or other numbers, other differences to equalize with the frequency that we fixed. That's the naive approach, but that is not going to work. Why it's not going to work? Because of certain examples. I have one example here. Okay, this is not the right. Okay, so 0, 11, 9, 6, 1, 15, 6, 0. There's no space. 12, 14. So this is another example. This is a good example. 0 to 14. What's the difference? 14. 12, 11. What's the difference? 1. 0, 9. What's the difference? 9. 6, 6. What's the difference? 0. 15. 1. What's the difference? 14. So 14 occurs twice. I will write it together. This occurs once, this occurs this occurs 1, this occurs one time. Alright, so let me do this. This is better. Now, what was the naive approach? Basically, we fix 14 and we try to use the other differences, change the other differences to get our answer. The answer will be 1. So basically, what was 1? 1 was this one. Here, what is k by the way? K is uh, k is 15. Alright. Now, between 11 and 12, what can I change? I actually need to change both. There's no other way. Because if I change one, the maximum difference that I can achieve is what? Either I can change 11 to 0, that will be 12, the difference. Either I can change 12 to 15, but that will be even lesser of a difference, right? So I don't need to even think about that. So this is the difference that I can achieve maximum by changing one value. If I change two values, then sure I can get the maximum difference. I don't need to worry about anything. So if I can get the maximum difference, I can definitely get 14, right? So now we are getting in the intuition of where we need to head. This is something that is going to help the maximum attainable difference between two numbers. So between 9 and 15, what's the maximum attainable difference? It's 9 and 15, so I can change 9 to 0, or I can change 15 to 15. There's nothing to change. If the k was 16, then I can change k to 16 and see if that is a candidate that I need to worry about. But here I don't need to worry about it, so I can change 0, I mean 9 to 0, and that will be 15, the difference. Fine. What is the maximum attainable difference between 6 and 1? Well, I can change 6 to 15. That's the best thing I think I can get. So that is 14. Alright. So if I would have changed 1 to 0 or 1 to 15, in that case it will be a difference that is lesser than 14. So this way, if I try to find the maximum attainable difference, and then I use this frequency to iterate, I mean, iterate the frequencies, and for 14, let me just clear this up a little. Okay, this goes here, this goes here. Let me find the maximum attainable difference. I'll pre-calculate it before I iterate this. So I'll have something called M, which will be what's the maximum attainable difference between 0 and 14? It's 14. It's 15, sorry. K is 15. What about this one? 11 and 12. It's 1. But the maximum attainable difference is 12. What about this one? It's 15 again. What about this one? It's 6 can be converted to 15, and 15 and 6 is 9, the difference. What about this one? This one will be 15 again. I'll convert 1 to 0, and this will be, okay, this will give me the difference as 15. Now I get this. So I have, suppose if I'm iterating this and I get in the frequency right now, there's nothing of the sort 13. If there was 13, suppose in the question, if I had a difference 13, in that case, what will be the answer for 13? The operations, the minimum number of operations required, what will be the answer? So 13 is having a pair in itself, isn't it? All right, it's good. I'll use this to not change this pair and change only the other pairs. What are the number of other pairs that I can find it from maximum or maximum attainable difference array that I have pre-calculated it. Since this can be sorted, before even sorting it, let's see how we are going to find it. 13. How many pairs are going to give me at least 13 difference? This is one pair. This is one pair, but it's not going to give me 13. This is one pair which will give me 13. This will another. This will be another pair which will give me 13. So 3 pairs will give me 13, out of which one I don't need to change because it's already 13, isn't it? So two operations I need to do. Okay, two operations I need to do at till now. So this was 3. So what are the remaining number of pairs? 1, 2, 3, 4, 5. 5 pairs. I get 3. So 2 pairs I need, which won't give me 13, right? Using one operation. So I can do two operations in it. So I can multiply by 2 and add this. This will be 4. 4 number of operations. Similarly, I can do for all the frequencies. I'll iterate and I'll get the minimum from those, and that will be my answer. Now, since I found out like this manually, but as a data structure, this is DSA, we need to do something optimally to find this number, right? So what are the values which is greater than 13 is what I'm trying to find. Or we can do the other way. What are the values which is smaller than 13? That is also doable. So in that case, we need to sort this maximum attainable difference and do a binary search over it to do this optimally. All right. So we'll take this. We'll do this in terms of code. We'll have something called frequency. I'll store it in map, but we can do it with frequency as well because, by the way, the most important observation is this one to get the intuition. Because if this was not given, then this problem would be more complicated. So we are given that nums of I is always lesser than equal to k. So whatever value is appearing in this array is always less than or equal to k. All right. So the frequency, since this is less than equal to k, right, we can also have a vector here to get the frequency. That will be more optimal. But that won't be a little, I mean, the map will make things easier in terms of cleaner code. So I'll be using that. I'll iterate. I'll also have something called max attainable difference. Max def is fine. Okay, the def is, I'll get it from here. This will be an absolute difference, and this will be minus nums of n. N will be the size minus I minus 1. This is the difference, and I will increase the map frequency by the diff amount. uh, I will have the max attainable difference value for this pair. Actually, this will go only till n by 2. My bad, I didn't notice that. This will be n by 2. And what's the maximum attainable difference? Okay, so nums of I and nums of n minus I minus 1. Instead of using that, I take it in a variable. So this is pair, right? So let me call it A is equal to nums of I and B is equal to nums of n minus I minus 1. Here instead of that, I'll be using A and B. Now what should be the maximum attainable difference? I can either change A to 0, right, or B to 0, or I can change A to 15 or B to 15. I mean, A to K or B to K, isn't it? So that's the only way that we can do. So that's nothing but max of, if I change A to 0, case A to 0, in that case my difference will be just B, isn't it? And if I choose to change B to 0, in that case my difference will be just A. So whichever is the maximum, I will take that. So my first value here will be max of A comma B, and the second case is either I change A to K or B to K, isn't it? So what's the difference here? It's going to be B minus K, uh, the absolute of B minus K, and here the difference will be the absolute of A minus K. So the difference I'll take is the, I'll just, okay, B minus K, or I should take K minus B, and K minus A. This is going to be the value. Since this is always going to be greater, so I'm not taking absolute difference here. K is always going to be greater than B and A. Fine. This is the maximum attainable difference. I'll add this in max diff. This is max ATT. Okay, so finally I have everything done. I just need to sort. Like I said, we need to sort this. Max diff dot begin, max diff dot end. Okay, so now we have something called answer, and which will be initially int max actually. We can have some other values as well, it doesn't matter, since we are going to do a minimize operation on that. So I'll iterate the frequency, isn't it? I'll iterate the map. I'll get A and B from this, and I'll do a lower bound check. How many are lesser? Okay, how many are lesser will be from a lower bound function, which I don't usually use, but this is a binary search and we can do that easily using this function in C++. Uh, or we can do a, the left and right, the approach that we always use for binary search, that is also doable. But I'll be using this, that will be on next diff dot begin, dot end, and that will be searching for A, and that will be my max diff dot begin. So this will give me, and just clear things up here and tell you what lower bound does. So if I have 30, 40, 50, 60, So lower bound, if I search for 45, this will give me the lower bound will give me this index 0, 1, 2. So whatever lesser elements beyond, I mean before this, will be the index itself. So two elements lesser than this, isn't it? Alright, so okay, so this will be the number of lesser elements. And what is the I mean, what are the number of greater elements then? And greater will be n by 2 minus lesser, and uh, what will be the answer then? Answer is equal to minimum of answer comma. Now we need to use the map frequency as well, right? We need to remove the number of elements which I don't even need to change. Number of pairs I don't even need to change. So greater is going to use one operation, but I'll remove the map, or that is basically B. Since I'm iterating, I'm getting A and B, so I'll use that, and 2 into lesser. So these many elements are lesser, so uh, that'll be taking two operations. So I'll return answer. Let's see if this works. It does. And the time complexity will be O of n log n. Essentially, we are sorting it, so it will be O of n log n. The space complexity will be O of n. All right. So that is three problems. The fourth problem I'll probably upload it tomorrow. Thanks, guys.